Alright, so today's notes are going to be on circles. And this is just a review of the parts of a circle that we'll be using later on. So, first of all, let's go ahead and draw a circle. What you want to do is just take any circular object. You can trace it to make a circle. So for me, I'm going to trace this. So there's my circle. And then you're also going to need a straight edge. Okay. So a circle is a set of all points that are the same distance from a given point, which in this case is the center of the circle. I'm just going to eye it for now. So what that means is from the center, every point, no matter where I place a point on this line, is the same distance away from that center. Okay. So here are some parts. We're going to first say that, okay, to identify a circle, you can give it any letter. For example, I'm going to just call this A. And you label the circle by putting letter next to the center, and we can call this circle A. We can also be looking at a point on the circle and the distance away from another point on the circle. So this right here, from here to here, which I'll go ahead and show with mine. We call that an arc. And you can identify an arc by, again, just using two letters. And I can call that arc CD. Okay, next. Oh, by the way, because of some of the ladies in period 7 who's asked to make my desk area a little prettier, look at that pretty paper. Kira, I hope you're satisfied. Shout out. Alright, here we go. Back to math. So now looking at this, we also know that there is something called a radius, which is the distance from the center of the circle to any point on the line. I'll go ahead and draw that. Make sure you're using a straight edge. And you name a radius again by using the center point and another point on that line. I'll call that point E. And so then you could easily just call that radius EA. Another radius that we could have possibly, or actually, another component of the circle will be the diameter, which is a point on the one end of the circle and a point at the other end of the circle. The only thing is the diameter must also cross the center. So it has to have those two parts. It has to reach from end to end and has to pass through the center, and that's called the diameter. Now let me go back and label this radius. So then, again, I'm just going to label this. Let's see what we haven't used. B and F. So then we could name this diameter BF. Okay. Something else that you might see is a chord, which is similar to diameter, whereas the diameter had to pass through that center. A chord does not have to. It's just 2 points on a line. And that's a chord. I'll label this, how about GH? So we'll call it chord GH. see, what else do we want to talk about? There is going to be, oh, I see, okay. We also have to notice that there is something, you see the diameter? Well, one side of the diameter goes from the center to the end, which we said that's a radius. So here we go, we see another radius here. Notice over here from A to F, that's another radius. So what we can conclude from that is, I'm going to say, skip a few lines because there's several more notes to take, but one thing that we definitely want to star is that one diameter equals 2 radii. Radii is just the plural way of saying radius. So what does that mean? That means that also one radius then would only give us half a diameter. Okay. Another thing that some other things that we will see here is that there's something called a central angle, and then there's also something called a sector. An central angle is an angle created by using the center as a vertex. And then for example here, I'll notice that there's an angle that is created by 2 radii. So that angle right here that we see is what we call a central angle. The area of space within that section, right here, so an area of space enclosed by 2 radii, we call that a sector. So let me go ahead and label that. This is a sector. S-E-C-T-O-R. So let's go back here. Yesterday, from period 5, Oscar mentioned and asked about what do all the angles inside of a circle add up to. And if we combine all the central angles, so here's one angle, you're going to notice that there is another angle right here. And then there's another angle right here. And this one we can tell is 180. Well, if we added together all of these central angles, it's going to come out to 360 degrees. So that's our next really important start point that I want you to write down. The sum of central angles equal 360 degrees. Okay. Knowing that information, that all the central angles equal 360 degrees, we can start solving some problems that deal with circle graphs. So let me give you an example. I'm going to bring our book over here. And over here, here's a problem that we say. They say they took a survey of people, and the circle graph shows the results to determine how people feel about keeping the penny. So some people say, you know, we really don't use the penny anymore, let's just get rid of it. And then some people obviously disagree. So looking at this circle graph, sorry for the glare, try to get rid of that. It says that 3% of people are uncertain. We don't know how many people were surveyed. They could have asked 100 people, they could have asked 200 people, we don't know. But however many people that they surveyed, 3% said that they don't know how they feel about keeping the penny or not. 32% are against keeping the penny, and then 65% are for keeping the penny. Well, if I ask you to recreate this graph, or in other words, how can you figure out the central angle of one of these sections? So for example, like what's the angle measurement from this angle right here, or this small angle within here? There's an easy way to do that, since we now know that all of the angles central angles in a penny equal 360 degrees. We're going to use our favorite friend, proportions. So this is actually our last part of our notes. It's short today. We're going to be solving circle graph problems. And I want to ask a question. What is the central angle or the degree within that circle graph that we just saw that we're against? If I look at this graph, I'm going to show you. We see that 32% of people are against keeping the penny. And we know that when we talk about percent, it's out of 100. So let's set up our proportions like this. 32%, in other words, 32 out of 100 are against keeping the penny. Well, I'm going to set proportionate to the total number of degrees within a circle, which we said was 360 degrees. Because I want to know what part of that circle represented 32%. So here's where we don't know. We're trying to figure that out. Once we figure that out, go ahead and cross multiply. We're going to say, okay, 32 times 360 equals 100x. When you multiply those two together, you should get 11520 equals 100x. Divide both sides by 100. And you end up getting 115.2 equals x. Go back to the original problem and say, okay, when we're solving for x, what were the units? I noticed that we're looking at 360 degrees, so x is also degrees. So this answer that we have down here is 115.2 degrees. Represents the 32% that are against keeping the penny. So we have solved the problem. Okay, that's it for today.